everyone, welcome to my YouTube channel. So here today we are going to be looking at sigma notation. So expressing in terms of sigma notation, we need to look, is it an AP or is it a GP? So if it is an AP, that simply means to say we are going to use the formula for an AP. If it is a GP, use the formula for a GP. Then some you are just going to be analyzing. So what are we going to have? For the first one, as you can see, n, 3n, 5n. So we are adding a 2n. n plus 2n is 3n plus 2n, that's 5n plus, until we reach that. Now what we are going to do is that we need to find how many terms are here if we have an end. So we are going to save using the AP. Since this is an AP, an should be equal to a plus the n minus 1 times the d, like that. So this gives us what is our a. So the first term according to this is n plus. Now differentiate this n. So we are going to say the number of terms. So n final. So we have minus 1 times. How do we find our d? So the common difference is found by subtracting the term number 2 minus the term number 1. So term number 2 is 3n. So we are going to say 3n minus n, which gives us a value of 2n. So we are going to put our 2n here. Then the final term, which is our an, is equal to 21n. So what do we have? Let's take this and do the needful. We are going to get our n goes the other side, so we have 21n minus n should be equal to nf minus 1 times our 2n, like that. So 21n minus n gives us 20n, should be equal to, we have our nf minus 1, then we have our 2n, like that. So we are going to, instead of multiplying everything, we are going to, but if you were to multiply, you can have 2 times this, it is 2n. n final, you should differentiate. These are not multiplying to have squared because this n is different. It's only that they used n. So we are going to have our 2, we divide on both sides. This gives us, so 2n, we divide, this gives us 10, should be equal to nf minus 1. So taking this side, it will be equal to 10 plus 1, which is equal to the final term. So in other words, this gives you the number of terms. So the number of terms, there are 11 terms. So there are 11 terms in this sequence. Now we are going to find the nth term. So the nth term is given as a plus n minus 1. Then we have our d. So we are going to have, what is our a? Our a is n. Then we have plus, how many terms do we have? We have 11. Sorry, the nth term. So we have our nth term. So let's just say nf. Then we have minus our 1 times the d, which is our 2n. So we can multiply. So this is the nth term. N, we have plus, this multiplies everything. So 2n times nf, it will be 2n times the nf, like that. 2n times negative 1, it will be minus our 2n, like that. So this gives us, we are going to have our 2n nf minus 2n plus this n. So we are just rearranging. So this is the nth term. So the nth term will be equal to, you have our 2n nf, then we have minus our n, like that. From here, factorize, n is common, so factorize, we are going to have our n is common, then you have your 2nf, then you have minus your 1, like that. So this is the nth term. So using the nth term, we can say, using the nth term, the sigma notation, which is the sigma notation, will be like this. Then we are going to have, we can even put n this other side, which is still okay. So the sigma notation will be equal to, we are going to have our 2 Now sigma notation, we mostly use I, so let's use I. So where there is let nf be equal to I, so we are going to say I like that, then we have a minus 1 like that, then times the n. Now remember, this is nf and this n are different, that's why we can't replace I for that. Then we have that. Now you can wonder, how can you get the value? So you can say that for which I is equal to from 1 until I, remember we have 11 terms. So for us to have 11 terms, the last value will be equal to 11 like that. So this is how we write the thing, because here from 1 to 11 there are 11 terms. 1, 2, 3, 4 until you get 11, you have 11 terms. That's the sigma notation for that one. So it's only that they were using the same letter n, that's why it was a bit confusing. So but the concept is very much okay and very easy. So let's look at this other one. If you have the second one, which is your 1 plus your 2 plus your 3 plus the dots plus the n. Now you might wonder, why did we make this nf to be I and not this one? Because we need, when we replace a value such as n, it comes back. Like for example, if you put 1 here, it will be 2, 1 minus 1, then outside there is n. So 2 minus 1 is 1 times the outside n, it will give you n. That's how come we have where is the n? That's how come we have the n here. So if you put I is equal to 2, if you put 2 as we continue, you are going to find that it will be your 2, then I is 2 minus 1, which will be 2 times 2 is 4 minus 1, that's a 3. 3 times the n outside gives us 3n. So that's why we are going to be having our 3n. So n should always be returning. That's the meaning. Then when we are here, you are going to find that we have 1, 2, 3, 4 until n. So the difference here, there is a difference. So 1 plus 1 is 2 plus 1, that's 3 plus. So we are just adding 1. So the difference will be term number 2 minus term number 1, which will be 3 minus term number 2 is 2. 2 minus 1, if you want it's term number 3. 3 minus 2, it will still give you the same answer. So this is the difference. So if you have found the difference, find the number of terms. So the number of terms, the nth term is given by a plus n minus 1 d. So what is our a? Our a is 1 plus what is our n? The number of terms, we are told that the last term is n, so we are going to use this n. So we have n terms which we don't know. We want to find the value, in short, the number of terms. Difference is 1. Then the nth term, the last term is n. So you use the last term to find that. So we are going to have 1 times this, it will just be plus n minus n should be equal to, we are finding the number of terms. Just by looking at this one, since this is not a number, I made a mistake. It could have been a number if it was like this, 3n, 5n, but these are pure numbers. So the number of terms here are n terms. So we are going to use n terms to find our summation. So using the nth term is equal to a plus our n minus 1 d. We are going to have our first term is 1 plus the nth n we don't know, so we have our n. We have our n minus 1 times the difference is 1. So the nth term is given by 1. 1 by this, it will be plus n. Then we have minus our 1 like that. 1 doesn't change anything. So we have 1 minus 1 is 0. So we have the nth term. So this is the formula of this sequence. So knowing the formula of the sequence, we can say, therefore, n is equal to I, so we are going to mostly be using I, so we are going to say this is the only thing we have, so we are going to put our I. Now from which number? So remember, we are moving from 1, we have 1, 2, 3, so that means to say we are going to put our I is equal to 1 until we just put our n. So this means that we are moving from 1 until, so we can put 1 plus, the second one will be 2 plus, the third one will be 3. So we are moving from 1 until n plus dots until we reach n. That's the meaning. So that is how you express for a full 5 marks question. Now for this one, you need to be careful. Let's see. Let's try to subtract if it is an AP. So the difference should be the same between this and this. So if you do that, you will have your term number 2 minus term number 1, which will be 5 over 6 minus 2 over 3. This gives us a 6 is common. 6 divided by 6 is 1 times 5. It will be 5 minus 6 divided by 3 is 2 times 2. It will be 4, which will be 1 over 6, like that. Likewise, you can subtract this and see whether it will give us the same. So D is equal to term number 3 minus term number 2, which gives us term number 3 is 1 minus 5 over the 6. This gives us a value that is equivalent to, we have 6 divided by 1, that's 6 times that, we have 6 minus the 5, which will be 1 over the 6, like that. So if the common difference is the same, you can say it is an AP. Therefore, use the nth term. We are going to say your nth term is such that you are going to have nth term should be equal to A plus our n minus 1 times the D. So the difference is 1/6. So you have so 4 minus 1, that is 3 over, where did this come from? It's supposed to be 6, like that. So that when you find the common denominator, we have 6 divided by 6 is we have 1. 6 divided by 6 is 1 times 3, so we have 3 plus the 6 divided by 6 is 1 times n, it will be n, like that. So this is our expression. So you're going to say the sigma notation of our, so let your n be equal to the I. So we are going to have the sigma notation from our I. Okay, first let's write the expression. So we have 3 plus the I, like that, over the 6. Then we are going to have what is our final term. So looking at this and looking at the sequence, so beginning at I is equal to 1 and the n value will be equal to what is the highest. So we have the first term, second term, third term, fourth term, fifth term, sixth term. So we are going to put 6. So we are going to just put our 6, like that. So this is the expression, like that. So this is the expression that is required. So you can verify that if you put 1 in I, you are going to have, let's say you put 1 there, it will be 3 plus 1 over 6, which will be 4 over 6. This can be reduced. 2 can enter into 4. 2 can enter into 6 to give you 3 for both cases. So we have 2 over the 3, like that. So we have our 2 over 3. If you put a 2, it will still be valid because 3 plus, it will be 3 plus 2 over 6, which will be 5 over 6. So for any, if you put 3, it will be 3 plus 3 over 6, which will be 6 over 6, which will be 1, which is here. So that is one of the sigma notations that you can be able to use. like that. There is another valid sigma notation for this one, which is that if you have I over 6 like that, I over 6 from I is equal to 4 to I is equal to from I to I is equal to, what is the highest value? To I is equal to 9. So how do you get to this one? So this one can be written in the sense that if you look here, we have 3, we have 6, we have 1, we have 6. So all these numbers can be written in terms of having the denominator 6. So we have, if we have 2 over 3 is the same as, we are just going to be multiplying by our 2 over the 2, the ones that don't have 6. So we are going to have, it will vary. So we are going to have, so this series is the same as the 4 over 6. 4 over 6 is the same as 2 over 3. If you reduce, 5 over 6, then we are adding plus our 1 is the same as having 6 over the 6. Then we have our 7 is the same as having plus, we have our 7 over 6 plus 4 over 3 is the same as having, so if you multiply 4 by 2 is 8 over 3 by 2 is 6, like that, plus finally 3 over 2. So to get to 6, you need to multiply by 3 down here, so that 2 times 3 gives you 6, but whatever you multiply on the denominator, multiply it on top. So 3 times 3 is 9. So this is the series. Then after doing that, you can now be able to say the summation of this is the same as, on top you have I over the 6, so that the 4 here you can start from I is equal to 4, so that from 4 to the I is equal to 9. So both of these are valid, but it matters on how you represent the work. So you can say for this second one, you can say changing the denominators to 6. These are the numbers. So what you can do is get these two, multiply. Whatever you multiply on top, you multiply at the bottom. You haven't changed anything by writing like this. Or you can go with this, but how you represent the work is what mostly matters under sigma notations. Let's look at our fourth one. It says that we have our 2. Let's move it. We have our 2 minus 4 plus 6. We have minus 8 plus 10 minus 12 plus 14. So what are we going to do? So as you can see, just be critical about these things. So you have a 2, you have a 4, you have a 6, we have 8, we have 10, we have... So what can you observe? These are multiples of 2. So we have 2, 4, 6, 8, 10, 12, 14. So for number 4, which is 2 minus 4 plus 6 minus 8 plus 10 minus 12 plus 14. So you can say that these are multiples, meaning when you multiply to multiples, this is multiples of 2. So this is part of the max. So that means to say the sigma notation will be equal to, we are going to have, the sigma notation will be equal to 2i. So if you multiply 2 times I, if I is equal to 1, it will give you 2. If I is equal to 2, it will give you 4. If I is equal to 3, it will give you 6. But what are you going to do? So what we are going to do is that, knowing fully that we have a negative, so what are we going to do? So we are going to say, since we have negatives and positives, we need a changing -1. Why do I say changing? It has to change. We cannot just multiply by -1. It means to say, how come we have positive, negative, positive, negative, like that? So what are we going to do? So this -1 will be accounted for by saying that, therefore the sigma notation will be able to become our -1 to the power of our -1 plus our 1, like that. Now why is this important? You will see. So we have then times the multiple, which will be something like this. Now why is this important? Because if 1 is changing, it means, let's say if I is equal to 1, it will be equal to -1 to the power of 1, -1 plus 1, which will be -1 to the power of 0, which will be equal to +1, like that. So if this is our positive 1, that means +1 times the 2i, it will give you 2i, which we want to see. Now, even our i is +1, so we have our 2. We are getting the first value. If I is equal to 2, we are going to find that it will be -1. We have a +2 minus, or negative, the negative is out, so +1. Then we have times our 2 times 2, which will be -1 to the power -2 plus 1, that will be -1. Then we have our 4. So -1 to the power -1, it will be -1 times our 4, which will give us a -4. So that is what we mean by we need a changing 1. So if the 1 is changing like that, then we are going to have from which interval. So from our I should be equal to 1 to, how many terms do we have? We have 1, 2, 3, 4, 5, 6, 7. So until 7. You can verify all of them. They are going to give you the same answer. Even at 7, you will find that -1 to the power of -7 plus 1, since the negative is outside, times 2, where there is I, you put 7. So we are going to have our -1 like that to the power of, so why did I put the negative here? So this is the changing one, not the negative here. So this is what we are going to have. So we have our 7 plus 1, it will be 8 times 2 times 7, which will give us 14 times -1 to the power a positive integer, a number that is even. We have +1, so that's how come we have 14. So sorry for that mistake. So you are supposed to have I plus 1, then the -1 will be changing there. So know this form, it's very, very important. So this is the sigma notation, like that. So just for the sake of marks, you can just show that your sigma notation is working. Then for the last one, it says, that we have this. Try to see if it is an AP. Try to see if it is an AP. By finding out whether it's an AP or not, it will help you. So verifying that it is an AP, we are going to get 1 plus I times, we have +2, then plus our 3 minus I, plus our 4 minus our 2I. So verifying if it is an AP, we find D. So D is equal to term number 2 minus term number 1. So term number 2 is 2 minus the first term, which is our 1 minus 1 plus I. So opening the bracket, it will be 2 minus 1 minus I, which will be 2 minus 1 will be equal to, we have 1 minus the I. So this is our common difference. Is it the same for term number 3 minus term number 2. So we verify term number 3 is equal to 4 minus 2i. Then we have minus term number 2. So minus term number, I hope we wrote correctly. Minus the term number 3, which is our 3 minus our I, like that, which will be, D should be equal to 4 minus 2i. Then we have minus 3, negative by negative, it will be positive I, like that, which will be, we have 4 minus 3 minus, we have our 2i plus our I, which gives us 4 minus 3 is 1, negative 2 plus I, it will be negative I. So it is an AP. This is part of the marks. So it is an AP. So after that, what are we going to do? So we are going to find the nth term, which is a plus n minus 1 d. So let us multiply. So we have 1 plus our I plus this n multiplies everything, so it will be n, open brackets, we have 1 minus I, then we have this negative 1 multiplies everything, so we have our 1 minus our I, like that. This gives us 1 plus our I plus n by n, n by 1 it will be n by this it will be minus ni, n by this it will be minus 1, negative 1 by this it will be positive I, like that. Then from there we are going to collect the like terms. So we have this I plus this I, so 1 minus 1 is 0, but don't do this, don't cancel, so that's 0. So we are just remaining with our I plus our I plus our n minus our ni. This gives us I plus I is 2i, like that. Then we have our minus ni, so that we have like terms for that. Then we have plus n. So there we are going to factorize. So we have our I is common. Then we are remaining with our 2 minus our n. Then we have plus our n, like that. So this is the equation, the nth term. Now why is I outside? We want I to be outside because all these terms have got I, like that. So we want it to be outside. So we are going to say the summation will be such that instead of using I, since I should not disappear, we are going to use n. But let's first write our I. Then we have 2 minus n. Then we have plus our n. So our I is equal to, so this n will be equal to some value which will be equivalent to, let's see what is working. If we put 1 for n, it will be, so if we put 1 for n, it will be 2 minus 1. Then we have plus our 1, like that. Then here we have I. 2 minus 1 is I, so it will be I, like that. So here the result is 1. 1 times I, it will be equal to I plus 1, like that. I plus our 1, like that, gives us this value. So if I plus 1 gives us the first term, it means to say it's starting at the first term, like that. So we have I is n should be equal to 1. Then the highest value we are going to go to is, let's look at it. We have infinite, so it's continuing like that. So that means to say we are ending at some term which we are going to call our n in this case. Now let's be careful. So since we don't want to cause any confusion, what are we going to do? So we are going to change this equation into having another letter. Since n is the one that is being used, we are going to say, in this case, let the n be equal to any letter r. If you want, you can use p, so that we avoid the confusion. So that means to say the equation will be like this: r and the r there. Yeah, so this will be the equation, so that one that is changing is r is equal to 1, then the nth term, it will end at n. So that is basically it. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.